You're about to start your second take-home algebra performance task. Make sure you've read the feedback for the first take-home performance task so you know how you did, and you've read your feedback on how I would like you to improve your performance for the second time if that's necessary. So the task in this case is solving linear systems of equations. So we will have a pair of linear equations and you'll be using one of the two methods to solve them. Those methods are described here in example 1 and in example 2 of the handout. So I believe you have copied solved examples 1 and 2 into your notes as a warm-up. And I believe you will have made some progress on the exercises you'll be expected to complete for test point scoring by the next time I see you. So I'm going to start number 1 with you right now. So everybody should have number 1 on their page, solved this way and formatted this way. You're going to start by copying the original exercise. So in this first step, don't change anything. Just copy it exactly the way it appears in this handout. And one of the notes you have is that when two equations are both in y equals mx plus b form, it's convenient to use the equal values method. If one of the equations has a variable by itself on one side, then that expression can replace the variable on in the second equation. That's what we're going to use here. We're going to substitute y equals negative 3x in equation number 2. So once you've chosen a method, go ahead and implement that method. So everywhere there's a y in the second equation, I'm going to use the y from the first equation. We know they're in system together. In other words, when graphed, there will be one point of intersection. So this is simply equation number 2 with the y from equation number 1. So 4x minus 3x is how I can simplify this, and I can combine like terms to find the x for this system. So already I know that the x has to be 2. I don't know where on x equals 2 the y will be, but it's easy enough to find out. Now I use x equals 2 in either equation to find y. Remember that the solution to a system of equations is an xy coordinate. Right now we have our x, we need our y. So let's go back to the original equations. Always keep track of these. This is why you've copied them exactly from the handout. And let's use the information that x equals 2. So y equals negative 3 times 2. So y equals negative 6. This completes the coordinate pair solution. But it's really important that we check. So just like the last time, I'm asking you to show the check. use the solution in both original equations. So, to use it in equation number 1, where y was equal to negative 3x, we take our y and substitute for y. And we take our x and substitute for x and see if we get a true statement. Negative 6 equals negative 3 times 2. Yes, we do. So it worked in that equation. So we know this point exists on the line given by y equals negative 3x. We also need to check the other equation. So let's check. For x plus y equals 2, we need 4 times x plus y equals 2. Is it true? 8 plus negative 6 equals 2. 2 equals 2. Yes, it checks in both equations. So it takes about 4 minutes per exercise to do a nice job on each of these. So pace yourself so that you're only spending a few minutes each day, and make sure you've got time to have your solutions checked and your formatting checked before the due date.